On the night of the 12th of August, something happens that almost nobody notices. The same new moon that slides in front of the sun during the day is, by definition, invisible at night. No moonlight. And that same night, the Perseid meteor shower reaches its peak. An eclipse in the afternoon, and then, after dark, up to 100 meteors an hour under a completely black sky. It is the same object causing both. But what you are actually watching is stranger than it looks. A meteor that streaks across the entire sky, bright enough to cast a shadow, is usually caused by something the size of a grain of sand. A pea makes a fireball. Nothing solid is coming down. Almost all of it is destroyed around 100 kilometers above your head. So why does a grain of sand produce that much light? The usual answer is friction. The particle rubs against the air, gets hot, and burns up. That is the explanation in most textbooks, and it is essentially wrong. The real mechanism is compression. A Perseid meteoroid hits the atmosphere at around 59 kilometers per second. That is far faster than air molecules can move out of the way. So instead of flowing around the particle, the air piles up in front of it and gets violently compressed. Compress a gas quickly enough and it heats. That is not exotic physics. It is the same reason a bicycle pump gets warm. But at 59 kilometers per second, the compression is so extreme that the air in front of the meteoroid reaches thousands of degrees. The particle is not rubbing against anything. It is being cooked by the air it is crushing. And the glow you see is not really the particle burning either. The heat strips electrons from the atoms in that column of air, and from the vaporized material coming off the meteoroid. What you are watching is a trail of ionized gas, glowing as those atoms recombine. The streak is longer and wider than the object by an enormous margin. Which is why altitude matters here. All of this happens roughly 80 to 120 kilometers up, in air so thin it is very close to vacuum. There is not enough gas up there to sustain a fire. Nothing is burning in the chemical sense at all. Now, where does it come from? Every Perseid is a fragment of a comet called Swift-Tuttle. Its nucleus is about 26 kilometers across, which makes it the largest object known to pass Earth repeatedly. It last came through the inner solar system in 1992, and it will not return until 2126. Each pass, the comet sheds dust and grit. That debris keeps orbiting, spread along the comet's path. Earth crosses the trail every August. We are not being hit by something. We are driving through it. That also explains something people get wrong about meteor showers. The meteors appear to radiate from one point in the sky, in the constellation Perseids. It looks like they are being fired from there. They are not. The particles are traveling on parallel paths, and the radiant is pure perspective, exactly like standing between railway tracks and watching them converge in the distance. Nothing is at the vanishing point. The Perseids are also known for fireballs, meteors brighter than the planet Jupiter, which briefly light the whole sky and leave a glowing trail behind them. That trail is ionized gas that can hang in the air and drift for 10 to 30 seconds after the meteor itself has gone. If you catch one, the useful trick is to stop following the meteor and look at where it was. For watching, the physics gives you the instructions. No telescope, no binoculars. You want the widest possible view, so lie back and take in as much sky as you can. Give your eyes at least 20 minutes to adapt and do not check your phone, because the adaptation resets almost instantly. Rates climb through the night and are highest between roughly 2 and 6 in the morning, when your side of the planet has rotated to face directly into the debris stream. And there is something quietly strange about all of it. The dust burning up above you was shed by a comet that no living person will see return. It has been drifting along that orbit for centuries. It is finally destroyed, silently, in a layer of air too thin to breathe, and it takes a fraction of a second. That is the shooting star you make a wish on.